Okay guys, today I just want to take care of some of the vocab that's going to be associated with the 9.1 notes. And Chapter 9 is all about this idea about polynomials. Now there's a really fancy definition of a polynomial. It is a function that can be written, not that it always is, can be written in the form some number a times x to the n plus number b times x to the n minus 1. That just means a lower exponent than the one before it, plus c times some letter x to the n minus 2. I'm going to use ... because this pattern keeps going all the way down to just some letter, let's call that d. Okay, because really there could be so many terms in here. I don't know how many terms a particular polynomial will have. That's what the ... means. But this x to the n minus 1, x to the n minus 2, what we're trying to show there is that we would write this as the exponents going in decreasing order from highest to lowest. So we actually already know several polynomials, like y equals x. That's a polynomial. There the exponent, or n, would be 1, and the number in front would be 1. It's a very uncomplicated polynomial. We know another, like y equals x squared, or another like y equals x cubed. Those are parent functions that we're all very familiar with, but they're also classified as polynomials. Now, up here in the definition, I said that a polynomial can be written in this form. It's not always presented to you in that form. A lot of times it is. But if we could write an equation like that, that means we've got a polynomial. Now that means, in other words, there are no variables in the exponent. If there were, that would be an exponential function, or denominator. That would be an inverse function. Also, the exponents are always positive integers. So back up here, these exponents will always be positive integers. They're never going to be a fraction, they're never going to be negative. If they are, it just means we don't have a polynomial. Now, when you guys are working with polynomials, you want to make sure that your final answer is always written in standard form. Now, that means that the terms are written in descending order according to their exponents. And that's, I think, most of the time what people do anyway. They're just used to writing it in standard form. There's some other vocab to take care of. One example of a polynomial is called a monomial. And that is when we have a number, or a variable, or the product of the two. So a couple examples could be 5, or x, or a product of the two, like 5x. Specifically, if we have a monomial with no variables, so only numbers, that's called a constant. So in my examples here for the first definition, the example of a constant would be the 5. Sometimes we'll have a monomial and we will have a numerical factor in front. That's called a coefficient. So, for example, if I did have 5x, the coefficient is 5. Sorry, that doesn't look like a 5. Specifically, there's something called the leading coefficient, and it will be the first number that you see when we are writing an answer in standard form. So for example, let's say I have something that looks like 2x cubed plus x plus 3. The 2 is the leading coefficient. Another very important word is going to be the word degree. It is the largest sum of exponents on an individual term of the polynomial. So for example, if I look at that polynomial that I just wrote above, this has a degree of 3. It's the term that has the highest exponent on it. We have monomials. Those are just one term, or one letter or one number or a product of the two. But a lot of times we have a polynomial that might be 2 terms, and we would call that a binomial. So for example, if I wrote x plus 3, that's a binomial. If I wrote 2x squared minus 5x, that's a binomial. We have another special word when we have a polynomial of 3 terms, and that would be a trinomial. Now, that would look like this. Something like maybe 3x to the 5th plus x plus 1. It has 3 different terms. Now, there are polynomials that have 4 terms, or 5 terms, or 6 terms. We don't have a special name for those. Just monomial, binomial, and trinomial. Let's put a little star next to those. Alright, let's flip it over. And let's talk a little bit more about the degree. You might remember this from Algebra 2. Degree, for some reason, they decided to give that the letter n. And depending on the degree, sometimes these polynomials are going to have special names. For instance, if we have a degree of 0, that means the highest exponent is 0. So that could look like that. We don't have an exponent on a variable. We call that a constant. That's kind of from the front, so that's not really different. When n equals 1, that means the highest exponent that I see is 1. So this has an exponent of 1. We would call that linear. And you're pretty familiar with that term. An exponent of 2. So for example, maybe that looks like this. That gets the name quadratic, something that you're familiar with already. If we have a degree of 3, maybe we have a function that looks like that. That would be labeled as a cubic. A degree of 4. This is where we get to something new. Well, it was last year, but new this year. We would call that a quartic. If we have a degree of 5, for example, like that. That's the highest exponent that you're going to see. That would be called a quintic. Now, after a degree of 5, we don't have any special names anymore. So like if we saw an exponent of 6 here instead, it wouldn't have a special name. So one thing I want us to be able to do is look at an expression and classify the polynomials by the number of terms, but also the number, or by its degree. So if we look at this first example, this has 1, 2, 3 terms. So that is going to be a trinomial. That's by the number of terms. The degree is the highest exponent. We see an exponent of 5, so that makes this a quintic. Down here, we have 1, 2, 3, 4 terms. There's no special name for that, so that's just a 4 term, but it's also a highest degree of 4, so it's quartic. We will practice classifying some more in class, but that'll wrap up these notes for now.